Our first problem is the dimension are B is equal to 42 millimeters and H is equal to 22 millimeters. Determine the y coordinate of the centroid of the beam's cross section. Flashing on your screen is the beam's free body diagram or the figure. So now we are going to find the required y centroid or y coordinate centroid of the beam. So first, to solve this, we can create composite shapes of the beam like this. I'm sorry for my drawing, and we can locate the a dot here, the centroids of each rectangular um, area or rectangular composite shape. So here is this is a 11 millimeter, the half of the 22 millimeters, and also the height of um, here is 120 millimeters, and this is in terms of y. Yes, this is in terms of y, and this is in terms of x. This is in terms of y, x. Okay, and we know the half of this is 60 millimeters. 60 millimeters, and here is the base is 42 millimeters. So how can we solve this? So first is we need to compute the areas of the box. So we can call this box 1, this is box 2, or rectangle 1, rectangle 2. So compute for the areas. So for the box 1 or rectangle 1, so A1 is equal to um, its base. I forgot. The base here is 200 millimeters from here. Okay, so we know the base times height is the formula for the area, finding the area of the rectangle. So base times the height is 22 millimeters. This is in millimeters, and what we got here is 4,400 millimeters squared. Next is the area for the second box, rectangle 2. Okay, this is the base is 42 millimeters times the height is 120 millimeters. So we have here is a 5040 millimeters squared. So next is our process is to find the um, y coordinate of each boxes centroids. So for the box 1, or y bar 1 is equal to 120 millimeters, or let's put the units because this is always millimeters. Okay, 120 millimeters. This is its height. Not height, plus 11. Height from here plus this height, so 11. This is from the vertical um, distance, so this will be 131 millimeters. And for the second box rectangle, we have 60, because the half of this box number 2 is of its vertical height is 120 divided by 2, so we have 60 millimeters. So now we can compute the centroid of the whole beam's cross section, y coordinate. So the y coordinate is we can use this formula, um, the area multiplied by its y coordinate centroid, or the sum of all um, the composite shapes area times the product of the area and the centroid y axis. So A1 will be 4,400 multiplied by its um, corresponding y centroid is 131, plus for the second box is 5040 millimeters squared times 60 millimeters. I mean, you can, and adding both the all the composite areas. So this will be 4,400 plus 5,040 millimeters squared. So if we compute this, we got that the centroid of the beam cross section in terms of y coordinate is 93.09 millimeters from its base. So probably it could be here. This is 120, so probably this could be here. This is the y. So this is the final answer. Now is our second problem. The 700 newtons force is applied to the 100 kilograms block, which is stationary before the force is applied. Determine the magnitude and direction of the friction force F exerted by the horizontal surface on the block. So now, flashing on your screen is the free body diagram. Okay, so the required here is the friction magnitude of the friction force and its direction. So now, assume that the whole system is in equilibrium. So we can um, equate all x forces to 0. So what is our x components here? So this will be the 70 newtons, and by from its angle, so this will be cosine 30 degrees minus the friction force is equal to 0. And if we solve this, the friction force is equal to 606.22 newtons. And next is for the y axis, or the sum of all y forces. So this will be the ano um this will be the normal force, and the minus the weight of the so to find the weight, since it is indicated in kilograms, we will multiply it through the gravity. So W will be 100 kg times 9.81 meters per second squared. So our weight here is 981 newtons. So this will be W minus the applied force. This will be P sine 30 degrees is equal to 0. So if we substitute the W or the weight, so this will be N is equal to 981 newtons minus 700 times sine 30 degrees, and what we have here is the normal force 631 newtons. So since we have a given of the static friction coefficient, so 0.8, and the kinetic friction coefficient is 0.6, and now we need to evaluate, or I mean find the friction force at the static or max static friction. So from the formula, 0.8 multiplied by the Newton, I mean normal force, which is equal to 631 newtons. So what we have here is 504.8 um, newtons. As you can see, the F max, Fs max is Fx max is lesser than the friction force from the here 606.22 newtons. So the body will move or have a constant friction, kinetic friction. So we can use the zero point 0.6 kinetic friction coefficient. So to find the kinetic friction force, so its coefficient 0 0.6 multiplied by the normal force 631 newtons. So what we have here is the um, 378.6 newtons. And since the possible direction of the block is going to the right, so since from the law of friction, the friction always um, in the direction opposite to the applied force or the movement direction of the object. So this will be going to the left. Positive but going to the left. That's the answer. So now here's our last problem. We need to compute the moment of inertia of the shaded region about y-axis by the process of integration. Flashing on your screen is the figure of the given problem, and we are required to find the moment of inertia about y-axis. So as you can see, the figure looks like a rectangle, so we can use the rectangle moment of inertia of y-axis. So about y-axis, so I sub y is equal to the integral of the lower boundary um, area x squared dA, and also we can use the dA is equal to y dx for the following process. So I sub y is equal to the upper boundary of the x axis and 0, upper boundary and the lower boundary, and x squared, since dA is equal to y dx, so we can equate this or substitute this expression. So dx, and this will be equal to, okay, let's move it here. This will be equal to continuation, um 90 over 0, 0 to 90 integrals x squared, substitute the y expression, y formula for the slope, 4 over 9 x plus 50 dx. So now we can distribute this, and this will be 90, this is integral, and this will be 4x cubed over 9 plus 50x, this is 50x squared dx. And now we can integrate this, integrating these, so we can have um, 4, and this will be 4 over 4, this will be 4 over x raised to 4 over 4, the 4 will be cancelled, so this will be x raised to 4 over 9 plus 50, so x cube, so this will be 50 over 3x cube. Y is equal to this is not y, this is x is equal to 90 and x is equal to 0. So substituting this from its upper and lower boundary, we can get here is 1.944 times 10 raised to 7 millimeters, millimeters raised to, millimeters raised to 4. I don't know, 4, but and this is the moment of inertia from the shaded region. This will be equal to I sub y. This is the final answer.